Hi there everyone, it's my pleasure to be part of PyCon Iran. My name is Trent McConaghy, and today I'm talking about smart contract development with TokenSPICE and Brownie. My whole talk will actually also be on slides that you can check out now or later. If you go to trentstreet/content/pycon.pdf, the link is at the bottom. With that, let's get started. This talk is for Python ML developers who are curious about blockchain, who might quickly become blockchain ninjas but don't know it yet, and I'm going to share how. The outline of my talk is as follows. I'm going to give two ninja strategies. First, a very quick, useful cheat, and then the bulk of the talk. First of all, a bit of background on smart contracts themselves, a ninja strategy part 2, which guides the rest of the talk. And then the rest of the talk is broken into 3 parts. How to leverage your Python skills directly for smart contract development using something called Ethereum Brownie. How to leverage your machine learning algorithm background for blockchain algorithms where they're similar. And finally, how to combine your Python and ML skills via a tool called TokenSPICE. So I'm going to focus on the tools of Brownie and TokenSPICE and kind of the wrapper around that. Let's get started. So first of all, a ninja strategy number 1, a useful cheat. So if you wanted to do Python and ML in blockchain land, but didn't want to do any Solidity development, that's the cheat, just don't do it. For ML use cases, here's a way. You can tokenize data and algorithms, share it, sell it, etc. using Ocean. And this is, a project I'm spending most of my time at, but I thought I would share it here with you. So from a Python perspective, the place to go is github.com/oceanprotocol/oceanpy. And as an example, on the bottom left here, this is how you would use Python to simply publish a data token, which is tokenizing a data set or an algorithm. You import the Ocean library, a couple more things. You set a private key from your environment variables, and then you create a wallet, which at the heart of a blockchain wallet is just simply holding that private key. But then once you have that wallet, it can easily sign transactions that then go on chain, etc. And finally, it's a single line to create this actual token itself, where you pass in the name of the token, some symbol, and then from the wallet. And the wallet is what's signing your private key against that transaction, and then also putting that on chain. And after that, you have an ERC20 token to represent that data set. So this is just giving you a flavor. That's not the focus of this talk, but if you want to get going quickly with Python and ML in Web3 and don't want to do any Solidity, this is a pretty good path. You could also, check it out, see what things can be for sale on market.oceanprotocol.com. So there's a web app for this too. Okay, let's focus on the bulk of this talk. First of all, background on smart contracts. So this slide describes a flow, a mental model for how things work in the Ethereum world and more generally the smart contract world. So there's, to start with, if you're developing a smart contract, it's smart contracts that are simply scripts running on a blockchain, and they do various things like manage funds, create tokens, all that. Step 1 would be you develop the smart contract, and I'll drill into what tools you use for that soon. You develop the smart contract, then you somehow verify it, and then finally you deploy it as a transaction onto the blockchain. And then the blockchain, you can think of it this sort of thing in the cloud, this decentralized cloud that's just out there, right? So the heart of it, the dark blue, is storage on chain, which holds the state. And then on top of that, you've got a virtual machine, such as the Ethereum Virtual Machine, EVM, which is running on the chain, typically part of the chain nodes, and they run smart contracts to update the state. That's the heart of it. So you've got the state, and the state gets updated via smart contract calls, or simply just direct transactions on ETH2. But the main stuff is the smart contract calls. So with this, going back to the left then, you have developed, verified, and deployed a smart contract, and now that gets stored as part of the state on the chain. But then if you want to use that, the main thing is you write a transaction, which is inside this, it's a call to the smart contract, calling some method in the smart contract, and then you sign that transaction and you submit it. Signing it means, adding your private key to say, yes, this was me. And then that gets submitted to the chain and it runs, and the state gets updated according to the functions in the smart contract. Also, you can read the state, there's read functions in smart contracts to get information, etc. Or you can just read directly with one of many tools. And then from that, you can get insight and take action. You can do this all independently, or you could develop and deploy a web app. So there might be development activities around that. And then that web app is doing this for you. And you would see that if you go to, Ocean Market or Uniswap or any of the other things. They've got smart contracts under the hood. But as far as the user is concerned, it's a web app, or in blockchain land, it's called a DApp, decentralized app. So that's the very basics of sort of mental model of how smart contracts are used. This is what a smart contract looks like. This is the language Solidity, which is the main smart contract language. It's used by more than 90% of smart contract developers. It's modeled a bit after JavaScript, meant to be simple to look at and understand. Like JavaScript, it started off pretty rough, but it keeps refining over time based on feedback and learning. In this case, there's a function definition, create token, passing in some arguments, such as a string for a blob, a string for the name, and so on. So in this case, this is part of the creating of a data token in Ocean. And under the hood, it includes a token template, which is a detailed template, another smart contract of an ERC20 token. ERC20 is just a fungible token standard. Within that ERC20 fungible token standard, you might have different functions, such as mint, which means mint more tokens, and there can be more. So this just gives you a flavor of what it looks like. If you want to see more from the Ocean side, it's github.com/oceanprotocol/contracts. And obviously there's tons and tons of contracts online in various GitHub repos and tutorials and so on. So then back to the tooling, when you develop a smart contract, you're typically writing in Solidity, which compiles to EVM bytecode that then goes on the chain. Most of the flows, it's kind of biased a bit towards developing web apps. So web apps, have JavaScript. There's a library called web3.js, which allows you to do the Ethereum transaction stuff. And then Truffle is a JavaScript-oriented tool to deploy contracts. And Ganache is a local blockchain. It basically runs a single node locally that you can interact with and develop quickly. And then, of course, the global ones in the cloud, there's things like Ethereum mainnet that are in production. And there's also test nets in the cloud, such as Rinkeby and Ropsten. After you've developed that smart contract with these tools, then, in verifying this, you want to use different tricks to verify it. So the main trick is reuse code. Smart contracts, there's a lot of different gotchas in smart contract development. So you want to avoid those gotchas, and the best way is simply to reuse other people's smart contracts and make minimal tweaks. Reuse battle-tested contracts, such as ERC20 contract implementations, or implementations for automated market makers like DEX, decentralized exchanges, and more. So reusing code is a key trick, and tweaking it if needed. And then you can have digital verification tools like Slither, and anyone doing stuff really seriously professionally also employs third-party auditors. And these are expensive, they take time, but it really makes a difference if you've got a lot of money on the line. Finally, you deploy it, once again using Truffle, like the first part. In the first part, you're deploying locally to your local chain called Ganache. In this case here, you're using Truffle to deploy to Ethereum mainnet, the chain. Besides that, when you're developing the web app, you're going to use typically JavaScript, web3.js, and other JavaScript libraries. And what's interesting is you can get away with not having to have any backend. A lot of the time people don't have things like Node.js or Django or anything running in the backend. They've just got the front end stuff. And that's kind of nice because then it follows the pure decentralized ideal. You've got JavaScript running locally in the browser client side, and then the rest is simply on-chain state. You can have things in between that are cached, etc., and some tools use this, things like the Graph or Ocean has Aquarius for metadata cache, and so on. But this is kind of the sort of ideal. Okay, so those are some of the tools. Yourself as a Python developer used to ML and Python is like, oh man, there's so much here, right? There's Solidity, JavaScript, Web3.js, Truffle, Ganache, all this stuff that you probably, you might not know, right? Typically, we're in a Python conference for ML and AI. So, the skills are Python and ML and the tools around that. So these are pretty unfamiliar tools. Myself, I've spent a good chunk of my career in Python and ML as well. And I can tell you for myself too, I feel much more comfortable in Python, etc. So what can we do about this to do effective smart contract development? and at the same time leverage our skills. And so, yeah, to summarize why this could look daunting, there's different languages, right? Solidity and JavaScript. This is not typical for MLers. Different tools, Web3.js, Truffle, Ganache, different building blocks. Instead of using neural networks and linear regression tools and so on, you're using things like ERC20, fungible token standard, ERC721, AMMs, multi-sig DAOs, all these other things that are, biggish ideas on their own in blockchain land, right? And there's other worries. Is it starting from zero? It looks like a long and steep learning curve. And yes, there's a lot to learn in crypto, but are you really starting from zero here? And is it worth it? It looks like in the end, it's building web apps, not ML algorithms. It's a different style of thinking. And if you're used to and you're good at developing algorithms and tuning them and so on, can you see a way to have leverage here to have an impact in blockchain? So that's kind of the questions. And I fortunately have some ideas and answers for you, or partial answers at least, hopefully. So what if the following? What if instead of a focus on Solidity and JS, it was mostly Python and some Solidity? And by the way, there is a smart contract language that is Python-like called Viper, V-Y-P-E-R, but it's hardly used. And then you can't reuse the building blocks. So I'm going to bias towards Solidity here. But I'm still going to say let's use mostly Python with some Solidity. So replace the JavaScript stuff with Python, and then Python as much as we can. Next, replace Web3.js Truffle Ganache with Brownie, mostly. Brownie is a Python library and command line environment that you can use. And I'll get into that in a lot more detail. Also Ganache, but it's going to be more hidden because Brownie will take care of it mostly for you. And finally, these building blocks like ERC20 fungible token standard and so on, here's the cool thing. You can treat them all as Python classes objects. It's not pretend that they are, it's that they literally are treated as that, and Brownie does this for you. So, we're all used to working with Python classes and objects. Now, what was previously just a Solidity smart contract is now a Python class. What was previously Solidity deployed to a chain as an instance on a chain is now a Python object, thanks to Brownie. Also, starting from zero, well, now actually you're able to leverage your Python and ML ninja skills. I'll show you how. And finally, are you really interested in building just web apps versus developing ML-like algorithms? And I can show you how TokenSPICE can help a lot and the ML-like algorithms are basically incentive type designs. And I'll show you what that looks like. So that's kind of, I'm hoping to point to, hope for ML people, Python people like yourselves, where you can have an impact sooner rather than later in blockchain land. So what does this look like from this conceptual picture? Well, developing smart contracts, you've got some Solidity, but it's now a lot more Python and Brownie Python. For verifying smart contracts, yes, there's code reuse, but now you're leveraging TokenSPICE a lot. For deploying smart contracts, you're using Brownie. For developing and deploying, don't focus on the web apps. Instead, focus on command line interface, focus on Jupyter notebooks, etc. So there's a lot of really interesting things that can be done at that level, at command line, and with other libraries like matplotlib, other numerical libraries, etc. So there's so much interesting stuff that can be done there. You don't have to resort to just building a web app. And so this is basically sort of a place to leverage your existing skills in a faster way for blockchain. I should mention, though, I can't beat around the bush here. You're going to have to understand Solidity to some degree if you want to do well with this. In my opinion, I think that the book Mastering Ethereum by Andreas Antonopoulos and Gav Wood is a great book, a great resource for that. You can find a lot of tutorials online, but if you want to have a pretty easy path to learn Solidity, understand the gotchas, all of that, this is second to none, in my view. And it doesn't have any real JavaScript inside it. It's just Solidity, as well as how to use wallets and all that other stuff. It really starts at some nice basics. Andreas also had written a great book on Bitcoin back in the day, and Gav was the main creator of the Ethereum Virtual Machine and the co-creator of Solidity language. So these guys really know their stuff. So let's go on to the next step. So how can we leverage our Python skills into blockchain land? And the answer is Brownie. So remember, Solidity and JS goes to mostly Py and via Brownie. So that's what we're going to do here. with that, I'm going to very quickly go through the Brownie Quickstarts. There are 3 Brownie Quickstarts. I'm just going to quickly survey them for you, and there are links here. And remember, at the beginning of this talk, it has the full link. It's trent.st/contents/pycon.pdf. And from that, you can recover the links. But I'm just going to go through here and walk you guys through. So let's go to the very first tutorial, which is called Getting Started with Brownie Part 1. And so it basically, so the idea is, go from this very rough approach where you don't really know what you're doing to maybe even a full-on ninja, but, one step at a time. So the first thing is installing things. And under the hood, it does have to have some JavaScript stuff, Node and stuff. You also do have to install Ganache. And there's a path for that, npm install Ganache. And you can see that it's installed correctly by checking the command line version. And then you have to make sure you have Python installed and pip or pipx. You can check there. So this is all just basic installation. You guys all surely have Python. Finally, the main thing is installing ETH Brownie. So pipx install ETH Brownie. And it might take a minute or two, but then once it's installed, you can simply type Brownie. And this is equivalent to typing Python. It takes you inside the interactive development environment. Basically, actually, it gives commands, but then there's a way to get to interactive. We'll get to that actually a bit later on. So it tells you different commands, and I'll show you the focus of that. But the main thing is you've got Brownie installed now, and that's it for this first tutorial. Of course, if you're a bit unlucky, then it might be a bit of a pain to get things like Ganache CLI installed and so on. But please persevere. Take the 10 minutes, take the 30 minutes, because once you've done it once, you're done for good. So that's the first part, installing Brownie. Second part is working with Brownie projects. And so going through here, so the main thing is when you're using Brownie, you're going to be using a project. A project consists of one or more smart contracts, unit tests, Python-style unit tests, PyTest in particular, and scripts to handle deployment and common interactions, right? So you can create your own project via just typing Brownie in it inside an empty folder. But to make it even simpler, for this tutorial, we're going to work from a pre-made project. And the way that you do that is via something called Brownie Bake. So to do that, you can just type, for example, Brownie Bake Token. And what it's going to do, it's going to grab from Brownie something called Token Mix, which is a simple ERC20 project. So you type Brownie Bake Token, then you can change CD into the directory, and it will show you a few different things. It will have pulled in a directory called contracts. And inside that, it's got Solidity files. So all Solidity files end with .sol. And by the way, it does work with Viper, but like mentioned, my focus here is Solidity because it's used probably 100x more than Viper is, and especially for the reuse of other contracts. There's interfaces, which basically has how to interface those smart contracts with other files. Think of it like C++ and C.h files. In this case, they're ABI files, ABI. And then there's a couple more things, scripts and tests. So once you have ran Brownie Bake Token, you can look inside. Then you can click Brownie Compile. And what it's doing is looking inside the contracts folder, the .sol files, and compiling them to EVM bytecode. And, it's a compiler, right? And then finally, with this, token, premix, you can actually, it also has some built-in tests. So if you type Brownie test, it's going to run tests for you. And in this case, it's just like any other type unit test, where it's, in this case, it's using the PyTest framework, of course. So you can see it's running test approved transfer from and test transfer. And 7 paths, and inside those modules, there's a total of 7 tests. You can also see what test coverage you have, which is a nice feature. And then it'll show you some outputs. Finally, about deployment, remember that was another piece of the flow. You can say Brownie run token, and it will deploy that, typically to Ganache because that is your local blockchain to test against, but you can actually point to other chains as well using the network flag, such as Rinkeby or Ropsten testnet, or Ethereum mainnet, or other production nets too, like Polygon. Finally, I hinted at this before, there's something called Brownie console, and this is the thing that looks like Python. So if you click at it, you type Brownie console, and it takes you inside what looks a lot like a Python console, and in fact, it has Python. But there's more inside that you can do to interact directly with the contracts. And that's what we're going to do now. So part 3. Whoops, have to go to part 3 here. Okay, part 3. Basic Brownie functionality. So we've installed Brownie and created a project. Let's go into the console and start playing. So first of all, just like any Python project, you can type dir and see the objects within that namespace, or the list of members within a project. For example, if you type dir, remember for this token project that we have, it will show you different things, but there's contract, there's fixed GUI, there's way, there's many, many things. And as you're glancing at this, you might be a bit confused, like what is what? That's okay. But among these, there's this thing called token. And token is from the smart contract called token.sol. So token.sol got compiled, and now when you're inside Brownie, Brownie knows to look at that token contract and make it available in an easy to use fashion for you here. Specifically, if you say dir token, normally you do this on an object or a class, right? In this case, token is being treated as a class in Python. This is the magic. So even though it was written as a smart contract in Solidity, thanks to Brownie, token is acting like a Python class. In fact, it is a Python class. It's just imported into Python Brownie this way. So inside that, token has some attributes like ABI and TX and more, but it also has methods such as deploy. So this is kind of the powerful thing. So inside there's a lot going on, and that's very, very nice. And it's a class that you can apply. So from that, and there's also help like usual. So to start with though, if you haven't used blockchain much, besides the Solidity contracts, there's also a basic unit of money called Ether. And in Ethereum, this is used to pay for transactions. So if you type accounts, what Brownie does is automatically creates 10 accounts that each have a bit of money inside. So that way you can pay for transactions up front. So, and this is actually done under the hood via Ganache, the local blockchain. But you can access them as this Python list. And each item in the list is a Python object called account. And it has information such as what's showing here is the address of that account. And an Ethereum address always starts with 0x. And so then what you can do, you can call one of these. So this account, it's a specifying account number 0. You can say transfer. So this is a method call to this object. And it's transferring to accounts number 1. And how much is it transferring? 1 Ether, right? And then what happens when you hit enter, Ganache, the local blockchain, mines the transaction immediately and outputs to the console. So you see here, it says transaction sent, and then it says transaction confirmed. So a block just happened in the local blockchain Ganache. And you can also look at the transaction receipt, which tells you details of the transaction itself. Now let's go drilling into working with contracts. So you can say token.deploy. So this token class, you can tell it to deploy, and then you pass in the arguments of the constructor of that smart contract. It's like the init function or init method in a Python class, right? So you pass this stuff in. In this case, it's got the symbol for the token, the name of the token, the number of decimals, and the maximum number of tokens that it can have. And then this last thing is saying which wallet are you signing the transaction with, right? In this case, it's account 0. A wallet is an account, is a wallet, basically. And then finally, when you deploy, you say token.deploy, like I said, and you hit enter, and it will send it as a transaction, and it'll put it onto the chain. And then this contract has its own address. right here, right? 0x602. So this is sitting inside the state of the blockchain. In this case, it's inside the state of the local Ganache blockchain. Yeah, you can see the details of this thing too. So token itself is the class, the overall class that has many tokens. But inside, it's actually also keeping track of the instances deployed. So token 0 is the one you just deployed. It's a Python object, right? So we say, let's declare the Python object as our local contract. And then we look inside that, and we'll see that this is the methods available of this object, this smart contract that has been deployed to the Ethereum chain. And finally, then also, because it's this particular contract is ERC20, you've got all the different ERC20 methods available, such as the total supply of these tokens, the balance of given accounts, and so on. And finally, we can actually look at the transaction itself, and we can see inside the transaction, there's also access to a lot of different values, what block it's in, what the contract address is, et cetera, et cetera, et cetera. So lots of different things. And it also has some error handling for if a transaction fails. And this is pretty cool too. The error handling in Brownie is very Pythonic. So even though you've got Solidity under the hood, you've got errors that look like Python. So rather than having to look into the guts of Ganache and transactions, it's trying to put it in a way, and it does a good job, of something that looks very Pythonic. And finally, you can also do tracebacks, which is also super cool. None of this is really that easy, but thanks to Brownie, it makes it easy. And that's kind of a summary of this first part, which is how to leverage your skills in Python to develop in Solidity. And that was a very quick start, but with that, you can go further. So if you just do a Google search for getting started with Brownie or follow the links here, then you'll find this for yourself and go for it. Next, ML algorithms to blockchain algorithms. So this is the aim, in blockchain land, what gets most of the attention is web apps, right? And those aren't ML-like algorithms. But what if we are working on ML-like algorithms? What does that even mean? In blockchain, it means incentives. So to quote Charlie Munger, who worked closely with Warren Buffett for decades, he has said, "Show me the incentive and I will show you the outcome." So incentives are these wildly powerful things. And the thing is, blockchains make them conceptually very easy to do. What does that mean? Get people to do stuff by paying them in tokens, i.e. ERC20 tokens or maybe NFTs. How do you implement these incentives in blockchains? It's the 3 steps I gave before in that picture. Develop, verify, and deploy Solidity code. So that's the heart of it, right? But then that Solidity code is shaped a particular way, just like Python code for Django is a different shape than Python code for ML. So we want, the equivalent here is the Python code for ML. It's much more continuous valued, etc., right? So to be precise, how do we design the incentives, right? It's, the problem of designing incentives is a lot like ML algorithm design. At the heart, it's an optimization problem. And the formulation of that is minimize one or many objectives, FIX, subject to constraints, inequality constraints and equality constraints, G and H. So this is design of analog or continuous valued systems. It's versus digital or discrete, right? This is something that ML algorithm is like. This is something that even analog circuit design is like, as well as blockchain, right? And in blockchain land, incentive design, when you apply rigor to it and really think about it from an engineering perspective, it's called token engineering. And then, how do you verify your design, those incentives? There's 3 ways. There's manual, getting human feedback, writing a white paper, talking with your friends, etc. There's economic, you just deploy the thing, start with low risk, but then you ratchet it up over time. And finally, software-based. But for that, you need appropriate software. What might that software look like? Well, let's get inspiration from the world of analog circuit design, tools for analog circuit design, where I spent a long time in my career. In circuit design, first of all, you design an analog circuit where someone is sitting down and drawing schematics, how things hook together, maybe some equation manipulation and so on. And then you verify it with a SPICE simulator. So you write down your netlist, your design, in some format that the simulator understands, and then you simulate and see results in waveforms with waveform viewers. And finally, the circuit gets manufactured. So that's analog. Here's what it looks like in blockchain land with incentives. You develop the smart contract. So maybe you draw out some netlist or something, but then you write it in a Solidity form. And this is what the Solidity form looks like on the right, like we've seen before. Then we verify with, instead of a circuit SPICE simulator, we have a TokenSPICE simulator that exists. I'll talk to that. So, and basically you're taking and wrapping this Solidity code with Python. So using Brownie, but then one layer up, you make agents. So it's an agent-based simulator that has EVM as part of it. And then you get results like the following. So it's waveforms, all of that too, just like you often see also when you're training a neural network or whatever. And then finally you deploy. So this is what it looks like with incentive design. What does this look like specifically? So remember, instead of starting from zero, we can use Python and ML ninja skills. That's your big lever coming from this world in PyCon. And instead, we're going to also use ML-like algorithms, and this is incentive design, like I've mentioned. So now let's drill into what TokenSPICE itself looks like. So let's go to that. So TokenSPICE is in GitHub at TokenSPICE, and it has its own README as well. And as you go through the README, basically there is an installation. So here, you simply git clone from the repo, and then you cd TokenSPICE. You create your own virtual env, you activate the environment, you install dependencies, and then you install some Brownie packages. But you do need to have a few things installed first, but you don't need to even install Brownie here. It comes with the requirements. Either way it works. Then TokenSPICE has its own CLI as well, called TSP, so you're going to use that from here on. The first thing you do is, assuming you have some smart contracts there already, and Brownie and TokenSPICE has them out of the box. That's TSP compile, and it uses Brownie to see smart contracts as classes. I've talked about that, and it shows the exact directories here. Finally, you can run and debug. So you can run unit tests here with PyTest, like any of you are used to. So this is a single test. You can run a whole directory. You can run the whole thing. You can also do static type checking, linting, and automatically fixing with black. So then the main guts of what TokenSPICE does is to simulate, right? And that is with the command tsp run. So, and within TokenSPICE, you are representing a netlist as a Python file. It's a simple Python file, but then it points to the wiring together of how things looked, like I showed before. When you run it, it basically does a loop, iterating. And the core idea of TokenSPICE is the following. What it's doing is it simulates by simply running a loop. At each iteration, each agent in the netlist takes a step. So there's a bunch of agents running around, and at each step, at each iteration, they take a step. That's it. And then a netlist simply wires up this collection of agents to interact in a given way. And each agent is a class. Each agent also has its own wallet. So then basically, like I mentioned, you've got this output happening. Then you can view the results visually via something called TSP plot. And then you can view the plots with some viewer like EOG. And that's a summary there. And then, resulting plots are kind of like I showed before, but here's some examples here of plots, right? Monthly DAO income versus time, annual revenue, many different possible things. And then basically the rest of this README just dives into the details of what agents are. So once again, TokenSPICE is an agent-based simulator with EVM, and it makes it's designed to be easy to verify smart contracts right here, right? And focusing especially on incentives. So that's the summary of TokenSPICE. So to conclude this talk, go back to here. The summary is, you and being in PyCon here know Python and ML, and you want to do cool stuff on a blockchain. So I presented two ninja strategies. One is skip Solidity altogether and use something like ocean.py that tokenizes data and algorithms. And then you can do a bunch of ML stuff, but with Web3. The second is, and that's the bulk of this talk, is do develop on Solidity, but focus on CLI type applications and use Brownie and TokenSPICE to make it feel and look a lot like Python development. You're still going to need to know Solidity, but beyond that, you're going to have a lot more power because you're not having to use JavaScript anywhere. And even most of the Solidity is feeling like Python and is basically acting like Python thanks to Brownie. With that, I conclude my talk, and thank you very much for your time.